Hi, this is Maggie from Design Code Debug Repeat. If you're a beginning programmer, a beginning game programmer, a programming teacher, a beginning data analyst, or if you just find this content interesting, please subscribe to the channel. I'll be posting lessons, tips, and cool programming stuff regularly. And this is another video that I think will mostly be of interest to people who are teaching programming, because I'm going to show you how to write a tracer problem using Cay Horstmann's code check system. And again, I want to say how thrilled I am that this system exists. So in the past, I've written the code check problems, which allow you to give the student a programming problem, they write the code, and then the code check system runs it on test cases. And what's a little bit newer is these tracer problems, which allow you to write code that the student can walk through. And so I am very new to writing these tracer problems, and this is going to be maybe my third or fourth tracer, so bear with me, but I want to share with you how to write these. So in the Problem Solving with Python Chapter 3 programming video, I write a program in stages, and this is the first stage of that program. And in the description of that video, I've got 3 different code check problems, and this is the first one, or this is the code that the first one is based on. So with the code check problems, I have those increments of the code, and the student can write increasingly more complex code in the code check problems. But I would also like to put at least one tracer in there. So I'm going to start with this simplest version of the program, and you can see it's quite simple. It gets an input from the user. If the user answered yes, then it appends something and then it prints out whatever that is, either the empty string or this string. So that's all. And what I'm going to do is take that code and I'm going to look at it here in Notepad++. Okay, so here's the code, and over here is the tracer. Now, the tracer is a JavaScript program, and again, we're going to be using Cay Horstmann's API. Now, I want to have on the screen, when the student is doing the tracer, I want them to see the code. I want them to have a terminal, because this is a terminal program, right? It's got input and output to the console. And a frame is where we have the variables, so where the student can see the program state. And I want to have a frame as well. So I import all of these at the top, the code, the frame, and the terminal. We're going to enclose our code in a template string. That's these backticks. Now, my JavaScript's rusty. I really don't think you need to know JavaScript to be able to do this. So I'm going to copy that code and I'm going to paste it over here. The reason I have it over here in another window is because we're going to be very dependent on these line numbers. And what I like about Notepad++ is it will show us the line numbers. So that's why I have it over here. All right, so when we've got the code, one thing that is important to know is that backslash is an escape character. So if we're going to have backslashes in here and we want them to be visible, then we need to escape them with an additional backslash. Okay, so I think my code should be fine here. Now these 2 parameters in sim.add at the beginning, where we're adding a new code object, a new terminal object, and a new frame object, these are coordinates. And the coordinate system is a little bit unexplained. So you kind of have to play with those to find the best coordinate system. So the code in this example is going to be on the left. I've got it at x0, y0, so left top. That is the one thing I know, is that the origin is at the top left. So the code will be at the left top, and then the terminal will be at the top right, and the vars will be below that. But they don't exactly line up. Anyway, we'll try those numbers. We can play around with those. That's not that important. Okay, so now we've got all our tools. This is going to give us our sort of objects on the screen that we can work with. So the next thing we do now is write the simulation, which is going to work with these three objects. And in the simulation, we have the option of moving a sort of a cursor forward through the code. And we can also pause and ask the user to enter values. We can pause and ask the user what line is going to execute next. And because the concept that's being introduced here is the if statement, branching programs, that's where I'm going to focus for this tracer. I'm going to focus on having the user click the next line. Okay, so we start by saying yield space and then sim.start state, and that's how we get started. And then we can say, for example, code.go, and we put a line number. So we can jump over, for example, this variable annotation for plain answer and jump right to this where packing list is getting a value, which is the empty string. So I look over here and I can see that that's line 2. So I can say code.go 2. Okay, now because packing list is now defined, I want to put packing list in my vars area. And so I'm going to say vars dot, and I'm going to call it by the same name because I'm sort of paralleling my code in these different areas. So vars dot packing list equals the empty string. And I can write a little line of text explaining what's going on by writing yield sim.next. Oops. Let's say initialize packing list to the empty string, for example. Okay, so then we might want to jump down to line 5, where we're interacting with the user through the terminal. Now, it is possible to allow the user, the student who's running our simulation, to enter values and use those in the simulation. For now, I'm going to simulate that the user of our program has entered yes. So again, I'm going to jump, and I'm going to jump down to line 5, which is getting this plain answer. But I want this text to go into the terminal. Now my terminal is called term, and it's got print and print line commands or messages. So I'm just going to print line that, and then also the user's answer yes. And again, I'm going to explain what's going on with yield sim.next, and I'll say something like the user enters yes at the prompt, something like that. Okay, so at this point, we could ask the user what line of code executes next. So in order to do that, we're going to write yield code.ask and then the line number that we want the user to click on. So it's line 8 that executes next. And even though that's just sequential flow of control and is not that interesting, I find that sometimes students don't understand that they will sometimes skip over an if statement, particularly if they think that the conditional code's not going to execute. They will skip right over the first line, which is reached sequentially, the line with the test. So in this case, I think they probably would click 8 because they know, hopefully, that line 9 is going to execute. But if we write the simulation with a no, they might actually skip right over this. All right, so we're going to say yield code.ask, and then nothing oh, whoops, I did forget something here. We need to put the answer to are you traveling by plane, because that gets stored in plain answer. We need to put that in our frame, which is called vars. So at that point we need to say vars dot plain answer, oops, dot plain answer equals, yes, so we have to mirror the state of the program as it executes. So we have to remember to update the terminal and update the variables as we go through. Okay, so now we can ask 8, and the user can now see in the variables that plain answer is yes. And then we can ask again, because we know line 9 will execute yield code.ask 9. And then at that point, again, we're going to update vars because packing list is going to get updated. So packing list is going to become headphones and reading material. Oh, I'm just thinking we don't want a new line at the top of this. Not sure why that's there. And then we can just go to line 12, and we can go, or we can wait at that point if we want to, by writing yield sim.pause, and then we can go to line 13, and that prints out to the terminal, so we need to ourselves mirror that term.println. Now we can print it so that we've got headphones on one line. That's what we do. And reading material on the next line. So we can make it look correct. Okay, so you are supposed to upload a tracer.js and an index.html with a description. I haven't done that before. We'll just upload the tracer.js, and then we'll see how much, like if index.html is a full HTML document or not. But let's upload the problem first. So this is called tracer.js. Actually, we could just do the index.html too. Let's do I have no idea, what's supposed to be here. And then, oops, and then here we put a description for the user, I guess. So we just put something like trace the program execution. Okay, let's see if we did that right. Okay, so we'll go to the public URL. Okay, so I'm seeing my document, but obviously there's an error. So let's go to edit. Okay, very stupid error of forgetting to put quotes around my strings. Okay, good. All right, so press start. Now, yeah, that's way down there. We want it more like up there, so we'll have to see if we can move it up there. Okay, packing list, initial packing list, empty string. Okay, these are enters yes at the prompt, and then we can see answer. Okay, select the next line to be executed. So let's see what happens if I click the wrong line. Oh, try again. Okay, good. Select the next line to be executed. Now the only thing here is I don't feel like it's super clear. I know that the way it looks changed. I don't feel it's super clear that I am again selecting the next line to be executed. Okay. And it printed out the results. So that was also a little abrupt. So we might put a few more messages in to the user and pauses just to let them know what's going on as the program executes. Okay, let's add our HTML file back in, which is index.html, and just see what it looks like with that. Okay, trace the program execution. So any special instructions or description we could put up here. Oh, and let's see if we can figure out. I think these are all the same. Yeah. That's the only problem with this is it generates so many windows. Okay, so let's see if we can figure out a better location. The terminal, I think, was an okay location. The frame was it too far to the left? And it was too low. Let's try 4. See how that looks. Okay. Oh, now it's too high. Well, let's try 15. Before, maybe it's, I don't know. I don't want to guess. Let's try 4 and 6. Okay, so, you know, 12 was, anyway, 6 is down here, but 4 was up there. I can't quite figure the coordinate system out, but you get the general idea. Okay, so this is a tracing problem that requires the user to click the next line to be executed. It does not require the user to enter any input. So why don't we modify this so that the user can enter either yes or no. And in the instructions, we could say something like, trace the program execution twice. Actually, I think that we can require them. Like, I think we could make it go right back up, but I'd rather not because it's not a loop, so I don't want to make it confusing. But I think we probably could jump back to line 1. But we can say something like, you know, trace the program execution twice, entering yes, no, and, you know, maybe or something for plain answer. So let's do that. Okay, I'm trying a couple of new values for where to put vars, and we'll see how that goes. And I've just added some more instructions here for the index, and let me just put that here as well. Okay, so what we would like to do with this, and I feel that I have not mastered this yet, but let's see how we can do with it, is instead of having us print a yes here, so instead of having an automatic yes, we want to get an answer from the user. I think that there are 2 ways to get an input from the user. And one is through the simulation itself, and that's up at the top of the simulation when it's running. And the other way is to get it through the terminal, but I haven't had, like, I think there are advantages and disadvantages to both. I haven't had a lot of luck with those either way. That neither of them feels supernatural to me. Let's try to do it this way. So I'm going to define a variable called plain answer. This is part of the JavaScript simulation. And we write let plain answer equal, and I think that this should return a string. I don't think we need to do any parsing, but you could use parse float or parse int if you need to change this to a numeric value. Term.ask, so you just wrap all of this in parentheses and then do parse float or parse int. Term.ask and then this instead of printing it, and then we want vars.plainAnswer to take the value of this variable which is in our simulation. Now the variable in the simulation would determine what line of code will execute next. So so if the variable, let's see, we're always going to go to 8, but if the variable is yes, then we're going to go to 9. And the variable will also determine what gets printed out. So I haven't actually tried to write anything like this before. But, so let's see, vars plain answer. So we don't need that because they've entered something at the prompt. Code.ask 8. So here I think we could say if now I can't remember if you can compare strings in JavaScript. I'm gonna have to check that. Give me a sec. Okay, we're going to want to use the strict equality operator. So plain answer equals yes. Then let's see, we're gonna code.ask 9, and that becomes the packing list. And then we could just do this whole thing, which I think, you know, could be improved. And else we want to ask them where they're going next, but they're not going to 9, they're going to go right to 12. So yield code.ask 12, and then they don't go to 13. So the program ends. Let's see how that works. Okay, so we'll just replace the whole thing because I made quite a lot of changes. I hope it runs. I hope it's syntactically correct. Oh, look at that. Okay, so here are my new instructions. And let's see. So we've got packing list. Oh, that's closer, I guess. Okay. Now, enter a new value. See how I don't see the prompt? I don't know how to get the prompt. Maybe I have to print it. Anyway, okay, so let's say they say yes, enter, okay, enter the next output, enter the new, oh, wait a minute, this isn't a prompt, this is what they are expected to enter. Now I get it. Isn't it fun to learn along with me? No, probably not. Okay, let's try that. I think I've understood that now. Let's edit. Haha, okay. Yes. Ha, okay. Now let's see if this part works. Select the next line to be executed. We said yes, so, well, it's always this one, whether we say yes or not. Now this one. Good job! Okay, and now I can start over as per the instructions. Start, next. Now we'll say no. Okay, select the next line to be executed. 8, good. Okay, select the next line to be executed. 12, yay, good job. Oh, okay. So, I'm excited because I just figured out how to do the console input and output, and we got that to work to give us different paths through the program. So I'm very excited about that. That's very cool. So there's a lot more that you can do with the tracing as well, and there are great instructions for this. Let's see, where are those? There's here you go, view samples and user guide. So I hope this will help you get started writing tracing problems, and then of course you can always reference the excellent user guide for more information. And I probably will record additional videos on this, as I said, as you can tell. I am really just learning to use this, but I'm so excited about it because you probably know that there's a correlation between students being able to quote-unquote run code mentally and their ability to program. And that doesn't mean, of course, that if we teach them to trace code, that they are automatically going to learn to be better programmers. But I think it is critically important that they do understand what lines are executing when and how they impact the state of the system. So I think that these are really, really important exercises, and I am just so grateful that Cay Horstmann has provided this system so that we can write our own. I hope you liked this video and I hope you found it helpful. If so, please give it a thumbs up. And if you enjoy this sort of content, if you find it useful, please subscribe to the channel. I'll be uploading cool programming stuff regularly. Take care.